All right, so this is going to be a video about the golden ratio, and we're actually going to solve what the golden ratio is equal to. But before I do that, I'm actually going to explain what the golden ratio is all about. Okay, the golden ratio is based on a length. So if you can imagine this length right here all the way across, it would be A plus B. You get A plus B. If you do the ratio of A over B, it should equal the ratio of the entire thing divided by A. Based on a ratio between two lengths and the sum of their lengths, essentially, to get what this golden ratio is. Now, this ratio is used in a lot of art pieces. It's used in a lot of things that are supposedly aesthetically pleasing based on the fact that this ratio is the most ideal ratio that you can have. Again, it's more opinion than anything, but either way, I think it's pretty cool because it just involves something simple as a ratio of some lengths and how they relate to each other. But it's basically the ratio of each bit of it, so the A and the B, is equal to the whole thing divided by the bigger bit, which is the A there. I think it's pretty cool. So to solve this out, what we're going to do is we're basically going to solve this thing right here, only we're going to set B equal to 1. Okay, so if B is equal to 1, then you're going to have this phi value right here that's equal to just A over 1, which is just going to be equal to A. So because phi is equal to A there, I'm going to replace all the A's with phi's then. So because B is equal to 1 in this case, what I'm going to do is phi is going to be equal to A. Well, that means A is equal to phi. So I can rewrite this to be phi over 1, which is this phi right here, is equal to phi plus 1, because the B is 1, divided by phi, since I just said A is equal to phi. First thing I'm going to do is multiply both sides by phi to get rid of the denominator so we don't have any fractions to deal with. So then you have phi squared is equal to phi plus 1. Okay, I'm going to subtract phi and 1 from both sides, and you're going to be left with phi squared minus phi minus 1 is equal to 0. I'm going to use quadratic formula on this, and you're going to get phi is equal to phi 1 plus or minus the square root of negative 1 squared is 1 minus 4ac, which is going to be 4 times 1 times negative 1, which is going to be negative 4. And then all of this is divided by 2. So this becomes a plus plus here, and you end up with 1 plus or minus the square root of 5 over 2 as being equal to the golden ratio. Okay, so if B is 1 and A is the longer, so the decimal approximations for this phi value would be 1.618 and negative 0.618. Now, if you notice, this A is a length, so you don't usually count this negative value here. I guess it could be viewed as like almost an excluded value, and you would have the approximation to be equal to this thing right here. Okay, so essentially, if B was equal to 1, A would have to be equal to 1.618, around 1.618, and basically, if you add that up, that 1.618 and 1, you'd get 2.618, and if you divide this by 1.618, it's going to be about equal to the 1.618 divided by 1, which is B. Okay, that's essentially what we found. We found the value that makes this thing right here true, if B is equal to 1. So that is a brief synopsis of what the golden ratio is all about. If you have any questions about anything in this video, let me know.